teach mechanical transitional system and also mechanical rotational system, okay, together with lever system and gearing system. Okay, so for today we're going to continue with 3 more systems: fluid system, thermal system, electrical system, and then we're going to continue with block diagram manipulation. I hope I will be able to cover all this topic for today. All right, so let's just continue with liquid level system. Okay, so liquid level system, there are 2 basic equations that govern the relationship between the parameters in this system. Okay, the first one is based on the fluid resistance. Okay, fluid resistance is R here. So the fluid resistance will relate between the flow rate and also the height of the liquid, height of the liquid in the tank. Okay, or we call it as a hydrostatic head, right? So basically, the relationship between flow rate and hydrostatic rate. Okay, flow rate is the how much liquid coming out and coming into the tank will affect the level of the liquid in the tank. Okay, so basically the relationship is not linear. However, here we consider a linear model approximation. We just approximate the behavior is some kind of linear. Okay, when we say it is an approximation model, meaning there is some parameters that we are omit in order to make in order to assume that this relationship is linear, right? So the linear equation, the linear model for liquid level system is given by equation Q is equal to H1 minus H2 divided by R. Okay, so Q is flow rate, right? It is liquid level. And R is the fluid resistance. Right? So the flow rate between 2 tanks will be based on the difference of liquid level in tank number 1, H1, minus tank number 2, H2, multiply with 1 over R, which is R is the fluid resistance. Right? That is our first equation for the liquid level system. The second equation is based on the capacitance in the tank. Okay, capacitance is actually how much it will able to hold the liquid in the tank. Okay, it's like volume. Okay, so the equation, okay, the equation is based on the theory that the changes in the volume inside the tank are equal to the difference between the input flow rate and the output flow rate. Okay, the capacitance is the cross-sectional area of the tank. Okay, basically it relate the capacitance is the cross-sectional area multiplied with the height give you volume. Okay, so this theory said that the volume inside the tank will be equal to the difference between input flow rate and the output flow rate. So therefore, the equation will be Qi minus Q naught is equal to C. C is capacitance that is considered as the cross-sectional area, multiply with dH per dt. Right, the changes of the height in time. Right, so we can simplify the equation to become Qi minus Q naught equal to CDH. Right, so this is the second equation for the liquid level system. Right, so we just need to understand or remember these two equations in order to analyze the behavior in a liquid level system. All right, so let's consider the system here. Okay, there is a one tank. Okay, Qi is the input flow rate, Q naught is output flow rate. Okay, H is the hydrostatic head or water level or liquid level, C is the capacitance, and R is the fluid resistance. Right, so we can write the equation for the liquid for this system based on the equation that we have discussed just now. Right, so based on the liquid level system, based on the fluid resistance, we're going to write the first equation, which is Q naught is equal to 1 over R. Okay, 1 over R is a constant, right? Multiply with the H. Okay, it's supposed to be multiplying with H1 minus H2. So let's consider this is H1 and this side is H2. But since H2 is no liquid level there, so we consider that to be 0. So therefore it's just H. Right, so that will be the first equation. Right, so remember this is variable, this is constant, and H is variable. Right, 1 over R is constant. Right, and then for the second equation, the equation is Qi minus Q naught will equal to CDH. Right, so that will be the second equation. All right, so based on these two equations, we'll be able to draw the block diagram if we know the input and the output. Okay, normally for liquid level system, input can be Qi or Q naught. Okay, input, but the output normally is H, the water level. Okay, the input can be Qi or Q naught, depend on the system, but the output normally is the water level height. All right, so other than this condition, you will also see system. Okay, two interacting tank, meaning there are two tanks, all right? C1 with input flow rate is Qi, okay, the height is H1, and then the output from the first tank is Q1, right? There is a resistance there R1, and then for the tank number 2, the input flow rate for the tank number 2 is Q1. Okay, the water level is H2, and then the output flow rate is Q0, right? And then you may also see a system. Okay, let me do additional tank here. H3, C3, R3. Let's say here is Q1, Q2, let's say. Right? Meaning the tank is interacting but at the different level. Okay, at the different level. Right? So if we write the equation, right? Let's consider the equation for the first tank. Right? Can you say the equation for tank number 1? Muhammad Nur Hafiz. Anyone? First equation for tank number 1. Okay, so we consider this part here first, right? So it is Q1 is equal to 1 over R1 multiplied with H1 minus H2. Okay, since H2, there is a level there, H2. So therefore H1 minus H2. Right, and then the second equation is for the tank number 1, the volume is equal to Q input to the tank number 1 minus Q output, which is Q1. Okay, Q1 is Q output for tank number 1, equal to C1 D H1. H1. Okay. All right, that is for the first tank. Okay, now for the second tank. What will be the equation for the second tank? Anyone? Second tank. Taufik tadi? Taufik?
I don't have idea.
Don't have idea. Lim Jin Yang? For tank number 2?
Hello. Q output equal to 1 over R2,
1 over R2
multiplied by H2.
H2. All right. Okay. Since after the valve, the liquid level is 0, right? So therefore, we only multiply with H2. Suppose H minus H something, but the second H not exist there, right? So that is the first equation for tank number 2. Right? How about the second equation for tank number 2? For the volume. Amirul Iman. Okay, yes, Kushawe, that's correct. Okay, Muhammad Wafi, correct? Okay, let's consider the volume. Okay, the volume in the tank will be equal to the difference between the input flow rate minus the output flow rate. Okay, so the input flow rate to the tank number 2 is Q1, and the output flow rate to the tank number 2 is Q out. Okay, equal to C2 D multiplied with H2. Right? So that will be the second equation for tank number 2. Okay, as for the tank number 3, okay, as for the tank number 3, again we consider that at the resistance here, okay, so therefore it is Q2 equal to 1 over R3 multiplied with H3. Okay, again, after the valve, the liquid level is considered as 0. Right, and then similar to the other tank, the input flow rate to the tank number 1 is Q0. Okay, the output is Q2, so minus Q2 equal to C3 D H3. Okay, so that will be the equation for the 3 tank. Okay, so you can see some part we got the tank having H1 minus H2. Okay, but some of the tank just we only consider 1 because the level is the other level is 0. All right, so we just need to determine which the input flow rate and the output flow rate in order to calculate for the volume. All right, so I believe you will be able to draw the block diagram because we have all the equations here. Okay. All right. Okay, so basically this one is similar to the one that we have discussed just now. Okay, so try to okay, let us try to solve this problem. All right, the first one is the input is Qi and the output is H2. H2 is here. This is output. Okay, so we're going to write the equation. Okay, Q0 is equal to 1 over R1 multiplied with H1 minus H2. That's the first equation. Second equation is Qi minus Q0 is equal to C1 D H1. That is the second equation. And then for tank number 2, Q is equal to 1 over R2 multiply with H2. Okay, that is third equation. Then Q0 minus Q. Okay, the input to second tank is Q0, and then the output is Q is equal to C2 D H2. That is our fourth equation. All right. So okay, the output is H2. Okay, so let's draw H2. Okay, so I'm going to use equation number 3. Equation number 3. H2 is Q multiplied with R2. We give you R3. All right, and then using equation 4. Okay, so Q is equal to Q0 minus C2D H2. Okay, so there will be a summation point there. Okay, here is the Q0, And this one here is C2DH2. Okay, so therefore, okay, C2D multiply with H2 as the input to the equation, then we get this part here. So it is plus here and minus here. Right, and then for Q naught, okay, Q naught, I'm going to use equation number 1. So Q naught is 1 over R, 1 over R1. The input is H1 minus H2. Okay, again, it is summation point. The input is H1 plus, and then I have H2 here. So, okay, so this one is minus. So this one here is H2. Okay, H1 minus H2. Right, so we left with equation 2. Okay, so H2 is 1 over C1D. Okay, because we rewrite the equation, H1 is equal to 1 over C1D multiplied with Qi minus Q naught. Right, so the input here is Qi minus Q naught. Therefore, there is summation point here. The input is Qi, and then Q naught is already there. This one is Q naught minus plus. So we just step from here to here. Okay, so that is the final block diagram, the complete block diagram. So we can see all the loop is there. Okay, the input is Qi. Okay, it will interact with all the parameters in the system that eventually provide the H2 as the output to the system. Right? As long as we have all the equation, you will be able to complete your block diagram. All right. Any question? Any question related to liquid level system? Maybe in terms of equation or maybe in terms of analysis. Diam je semua pagi ni. Ngantuk Alright, if no question, let's continue with second system. Right? Okay, the second system is thermal system. Right, so basically the equation for the thermal system is similar to the equation for liquid level system. Right, so in thermal system we have thermal capacity C. As compared to liquid level system, we have also C, which is the liquid capacitance. Okay, in here we have thermal resistance R. In liquid level, we also have R, which is the liquid resistance. Okay, and then we have Hi and H naught, which is the input heat rate. Okay, whether it is input or output. So Hi is input heat rate. Okay, H naught. Okay, this one is here is H naught. Output heat rate. Okay, so it is similar to Qi and Q naught. Okay, then for thermal system we have temperature. Okay, in degrees Celsius. For liquid level we have H, which is in meter. All right. So the equation is similar. Okay, the first one here is similar to the first equation. Okay, it is H naught equal to theta over R. Okay, I think the diagram is not very clear, right? Okay, it's actually H naught equal to theta over R. Okay. again, it is actually the difference between temperature between two room. We can consider that as a room, okay. But here we consider only one room, so the theta is only 1. Then the resistance is R there. Right, so it is similar to Q equal to H over R. Right, and then for the second equation, right, the theory for the second equation is based on the heat balance equation, meaning the heat in the container or in the room will equal to the difference between the input heat rate minus the output heat rate. Okay, so it is Hi minus H naught equal to CD theta. Right, so it's similar to the second equation in the water level system. Right, so if you remember liquid level system, you should be able to remember the thermal system. Right, so this one is constant, C and R is constant, and this one is variable. Okay. Right, we're not going to draw a block diagram. Basically, we just want to know the equation and also the analysis there. Okay, for the thermal system, the analysis is very much similar, but of course, there is no, because there is no level for the temperature, but it just depends on the difference of the temperature. All right, the last one is electrical system. Okay, in electrical system, we have 3 elements. Okay, the first one is resistor, inductance, and capacitance. Okay, so I believe you already know the equation for resistance, inductance, and capacitance. Right, resistance is VR is equal to I multiplied with R. Right, V equal to IR. Okay, inductance, VL is equal to L multiplied with DI. Okay, DI over DT. All right. Okay, anyone know the equation for capacitance? Anyone? Anyone want to give input?
Q is equals to CV.
Q is equal to CV.
Oh.
Okay. Q to CV. Right. Right. Yes. The capacitance will have an effect with a relationship with Q. Q is the charge, right? But in here, in order to calculate there, this is also the equation can be used. This equation Q equal to CV also can be used. But for the analysis here, we're going to use I equal to C dV. Okay. Meaning current is equal to capacitor multiplied with the change of voltage in capacitance. Okay. All right. Okay, so that is the 3 elements in electrical system. Then in order to analyze electrical system, normally we use Kirchhoff law in order to do the analysis, meaning to have relationship between all the elements in a circuit. Okay. Alright, so so for this example number 1, okay, example number 1, we have VI is the input, okay, and V naught here is the output. Alright, so here we have inductance, we have capacitance, and we have resistance. Okay, so based on the Kirchhoff law, we know that V output is equal to V input minus load. Okay, minus all the load in the circuit. Okay, so based on that, we have V out equal to V in minus VL minus VC. Okay, and then we also know that V out is equal to VR. Okay, for this part here, V out is equal to V for the resistance. Right, so this one will become the first equation. This one is second equation. Then we have the equation for all the elements. So let's say VL is equal to L multiplied with DI. Okay, that is the third equation. For the capacitance, I equal to CD VC. Okay, that is the fourth equation. And then for VR is equal to IR. That is the fifth equation. Alright. So the block diagram, V out. Okay. Equation number 1, equation number 2, V out. Okay. Let's use equation number 1. Okay, it is a summation point. Not very suitable to use equation number 1. Let's use equation number 2. Alright, so V out is equal to VR, since VR is IR. I multiplied with R, so we will get VR there, VR, which is equivalent to V naught. Okay, so then we can solve for I. Okay, let's use equation 4. I is equal to VC multiplied with CD. Okay. Alright, now let's solve for VC. So we're going to use equation number 1. Okay, from equation number 1, VC is VI plus minus VL, and then minus V out, Okay, so V out is here. Okay, and then for VL, it is LDI. Okay, so I is there. LD. I multiply with LD will give you VL. Okay, so Okay, that is the complete block diagram for a circuit that contain inductance, capacitance, and resistance. Okay, so the analysis for the circuit will be based on the Kirchhoff law. Okay. All right, so that's all the equation, the system in the first part. Okay, the first part is we learn how to draw a block diagram for any given dynamic system. So the system that we have learned is mechanical transitional system, mechanical rotational system, together with leverage and gear system. And then we have liquid level system, we have thermal system, and then we have electrical system. Okay, so by now you should be able to draw a block diagram. You should be able to analyze any given system, maybe in terms of mechanical transitional system, mechanical rotational system, or a combination of both transitional and mechanical system. Okay, together with leverage system and gearing system, right? And then there is also liquid level system, thermal system, and additionally electrical system, right? You should be able to analyze all the system, coming out with all the governing equation for the system based on the basic equation that we have learned, and then based on the equation there, you will be able to draw the block diagram. Okay, so that is the first part. We have complete the first part. Right, as the second part, we're going to continue with the second part is actually to get the final transfer function. Okay, as okay, for example, in this block diagram here, okay, you can see in this block diagram, the input is Qi and the output is H2. And we do know that we apply a Qi, meaning we set the input Qi, and then the Qi we interact with all the other parameters there. You can see H1, Qi, then you provide you H1, and then we provide you Q0, and eventually it will give you H2, which is the output to the system. Normally, we want to simplify this, okay, so that the system will only be represented by only one block. Okay, so normally we just want to have one block. Okay, the input is Qi and the output is H2. Okay, so you need to simplify this, simplify the block diagram. Okay, this block diagram is quite complex, right? So we need to simplify that such that it will become only one block that relates between Qi and H2. Okay, that will be the objective for the second part of this chapter. Okay, so before we start with that, do you have any question at all related to drawing a block diagram for any system? Because after this, I'm not going to touch with that part anymore.
Okay.
Yes.
I have a question to ask. So, untuk the block diagram, memang pun actually when we wanted to start it, we will always start with a formula that has only the multiplication only. If you want to start it lah.
Not necessarily.
Not necessarily.
You can start with the equation that contain plus or minus, but it's that it will you can do that, but just now I omit that because of the space. Okay, it's quite difficult to draw, but you still can do it. Okay, it doesn't meaning it's not wrong to start that. The block diagram is also not wrong. Okay, but if we draw, meaning if we use the equation just now, like this, right?
Yes.
Okay, so there will be part here. So you can draw, so maybe you can make it longer here so that you'll be able to draw something here. Okay. So the meaning here, yes, you can start with equation number 1. You can start with that, equation number 1. Okay. So la ilaha illallah. Sekejap. So basically you can draw, but you can see that there is some part here, so you need to adjust the space there. Okay, so it's not wrong. So try to do it so you can see the step there. Okay.
Okay. Thank you, Doctor.
Right. All right. So let's us have a break for about 5 minutes so I can prepare for the second part, which is the block diagram manipulation. All right. So let's continue after 5 minutes. And the second one is signal flow graph. Okay, we're going to convert the block diagram into signal flow graph, and then we use Mason's rule to determine the final transfer function. Right. So as for today, we're going to learn the method block diagram simplification. All right. So just now I already introduced to you about transfer function. Okay, in a detailed manner, in a correct way. The transfer function is a relationship between the input and output. Okay, and normally it is in terms of a linear model. Okay, and the transfer function is defined using Laplace transform. Okay, I believe you already learned about Laplace transformation in ODE. Okay, so basically for a transfer function, we use Laplace transformation method with considering the initial condition, right? Initial condition equal to 0, and then we solve the equation, we get the solution, meaning you're going to solve all the parameters there using partial fraction method. Okay, first step, of course, Laplace transform. You convert your final transfer function into Laplace form. Okay, and then you solve for the parameters using partial fraction method, and then you will inverse back the Laplace transform into the ODE again. So the final equation in ODE form is actually the time response and also the transfer function for the system. All right. So Okay, so we use the transfer function to describe the dynamic behavior. Okay, meaning we want to see how the output will behave when we apply the input. So we can see the dynamic behavior, how it change. Okay, so normally it is in time. Okay, the changes is in time. So we can see first we go up, then we go down, go up, go down. So that is what we call as dynamic behavior, that the behavior is changing. All right. We also use a transfer function to describe the relationship between the system input and output. Okay. Right. First, we describe the dynamic behavior, and then we use that to discuss the relationship between the input and output. Okay. So we can see how the system change when we apply the input. And then we will be able to see the behavior in terms of output. All right, but the transfer function, by using transfer function method, we do not have information about, okay, does not provide information about internal structure and internal behavior of the system. Okay, because we just consider the input and output. But in the transfer function, actually, there are many other elements, but we just combine it together. So if you only have the transfer function without knowing other element, so you cannot determine what are other elements in there. So because the transfer function cannot provide the information about the internal structure of the system and also the internal behavior of each of elements in the system. Okay, so we can just see the behavior of the system based on the input and output. Okay, but in the system, internally, we cannot do the analysis on that. Okay, the information about internal structure, internal behavior can be get if you're using a block diagram system. Okay, meaning we draw the block diagram, so we can get, we can know the flow, we can know the internal behavior, meaning for the spring, how it will behave, for the damper, how it will behave, for the mass, how it will behave. We will be able to see that. Okay, all right. All right, so let's consider a transfer function that represent by the following differential equation. Okay, so this is the transfer function. Here, x is the output. Okay, FA is the input. Okay, so we apply FA to the system, and then it will the displacement x will change. Okay, where based on the input given, whether the input is pulse wave, step input, sinusoidal input, so that the output will behave depend on the type of the input. Okay, so so if we write the normally we're going to write the transfer function is the ratio of the output over input. Okay, this is transfer function. Ratio of output, x is our output, to the input, which is FA. Okay, so therefore the equation will be like this. So first we need to separate x from there. So we have md squared x, okay, plus cdx plus kx equal to FA. Okay, notice FA is in time because x also in time. Okay, but because there is d over dt, so we just write x there. All right, so we're going to separate this. So we have MD2 square, MD2 square plus CD plus K multiplied with X is equal to FA. Okay, so if in terms of transfer function, it will become X over FA is equal to 1 over MD square plus CD plus K. Okay, so this is the transfer function. Right, so 1 over MD square plus CD plus K is the transfer function, where we know M is the mass, C is the damping coefficient, K is the spring stiffness coefficient. So we will have the value there, right? So it will depend on the system itself, how much weight of the mass, how much damping in the system, and how stiff is the spring in the system. So different design of the system will provide you different output. Okay, so this is the example of transfer function. So now the objective of our part here is to determine the final transfer function here, which is 1 over MD square plus CD plus K. Okay, or 1 over JD square plus BD plus K. Okay, or kalau liquid level 1 over liquid level ada apa tadi? CD, okay, CD capacitance CD and 1 over R. Okay, so all the constant that will be in the transfer function. Right. So now we're going to get the final transfer function here based on the block diagram that we have drawn. Okay, so okay, for example, this block diagram. Okay, as I explained before, this block diagram. Okay, we're going to get the final transfer function. So the transfer function maybe become like this: R1 over C1D plus C2D plus R2. I don't know. Okay, this is just an example. Okay, so we want to get this final transfer function, but we're going to use the block diagram simplification method. All right, meaning here block diagram simplification method is we will need to simplify this block diagram. Okay, so there are actually basic 5 basic rules. Okay, we can use. Okay, maybe we need to move this block pick off point. Okay, maybe to here or to here. Okay, we need to move this maybe to somewhere else, maybe to here. Okay, we can solve the feedback loops. Okay, so we will do that step and eventually we will get the final transfer function. Okay, all right, so this is the basic rules, the concept in block diagram manipulation methods. Okay, all right, so the first one here is to explain about summation point. Okay, here you can see that whether this diagram, this one is similar to this one, okay, or this diagram, it is actually the same. Okay, the output is the same: A minus B plus C, A minus B plus C, and A minus B plus C. The output is the same. Okay, so meaning whether you draw like this, okay, this is normally you draw like this, like Okay, you said there are three variables A, B, and C. So therefore, you will draw three arrows into the summation point, right? But other than that, you can also draw like this. Okay, so meaning A minus B plus C. So let's consider here is A minus B, and this one is plus C. Okay, so therefore we're going to solve for A minus B. So two variables, two arrows, A, B. Okay, it is the same, right? And the parameter is also, meaning you can put B first, A minus C first, A plus C, then only minus B, as in this diagram. Okay, so here A minus B plus C. Okay, three variables, but we want to draw only two arrows. Okay, only two arrows. So we said A plus C for this one, and here is minus B. Okay, so now we solve for A plus C, two arrows, A plus C. Okay, so this three diagram is the same. Okay, it will provide the same output. All right, that is the concept in block diagram there. Okay, so when you draw a block diagram, it's not necessarily to draw just this one, three variables T arrow. You can separate to multiple summation point. Okay. Okay. For the concept of block diagram simplification method, okay, meaning if you see there are two summation point side by side. Okay, like this one here. Two summation point side by side. Then you can just combine it together, become one, like this. Okay, can become like this. Okay, or you see it is one summation point, but you want to separate it into two summation point. You can also do that. Okay. All right. All right. Okay. I said just now we have 5 basics rule. Okay. The first one here is not considered because this is just a concept. Okay. Okay. The first rule that I means is okay. Here we have a series block. Okay. So for a series block, you can, in terms of positioning, it doesn't matter G1, G2 first or G2, G1 first. It will be the same, right? So for a series block, this is the simplification. After simplification, it will become one block only, where you will need to multiply both block together. So for series block diagram, we're going to multiply it. Okay, so therefore we have G1, G2 or G2, G1. It is the same. All right, so that is the first rule. All right. First one is series block. Okay, the second one sorry, saya kejap. All right, sorry for that. Okay. Okay, first rules is series block. Okay, series block, you're going to multiply it. Second rules is summation point. Okay, summation point. Here, sometimes the summation point will, due to the summation point, we will not able to solve a series block or a parallel block. Okay, later I will show you the parallel block. Okay, so due to the summation point and peak of point, we cannot solve that. Okay, for example, if there is summation point here, okay, so we cannot multiply it. Okay, we will need to move it first. All right, so the choice is either you move the summation point toward the output, okay, because we consider this side is output, or you move toward the input. Okay, after you move it, then only you can multiply G1 and G2. You can combine it together. Okay, but if there is a summation point or peak of point between the block, then you cannot combine it. We will need to move it first. Okay, so for a summation point and peak of point, we can move summation point either toward the output or toward the input. Okay, it will be different. The transfer function will be different if we move toward the output, and then if we move toward the input, it will also be different. All right. So all right, first is summation point here. So for this rules here, this is when you move the summation point toward the output. Okay, so here you can see you move toward the output. So now the summation point is after the G block. Okay, because you move over G toward the output. Okay, so after you move toward the output over G, therefore you need to multiply with G. Okay, meaning there will be additional block there. Okay, before this there is nothing here, for example like this. So when you move it toward the output, now there is a new G will be multiplied, B here will be multiplied with G. Okay, this block here is due to the moving step, because you move the summation point, therefore you need to multiply with G, right? So that is when you move the summation point toward the output. Right? For this one here, right? This is when you move the summation point toward the input. Okay, this is when you move the summation point toward the input. So here you can see the new transfer function, and the new meaning you need to multiply with 1 over G. Okay, 1 over G. Right? Okay. For these two here, this is peak of point. Okay, so you just tap and fit into somewhere. Right? So here for peak of point, this one here is when you move toward the input. Okay, therefore you're going to multiply it with G. Okay, and this one here you move toward the output, right? So you're going to multiply with 1 over G. Okay, so that is for rules number 2 and 3. First one is series. Number 2 is moving a summation point, but there will be 2 there, toward the input and toward the output. And the third one is moving a peak off point. Okay, there will be also 2 toward the input and toward the output. Okay. All right. So to simplify that, we just remember 1 because it just vice versa. Okay. So you just remember that a summation point toward the output, okay, then it will multiply with G. Okay, because if you move toward the input, it will become over G, multiply with 1 over G. Okay, as the peak off point toward the output, it will be vice versa from this one here, so it is 1 over G. Right, and last one, peak off point toward the input. Okay, vice versa with this one, so it is G. Okay, so therefore just remember one, summation point toward the output is G. Okay, from there you will be able to determine for the other movement. Okay, any question so far? Okay, we have three rules so far. Series block diagram, you're going to multiply it. Okay, moving a summation point, you will have two, toward the output and toward the input, whether you multiply with G or 1 over G, right? And then for the peak off point, it's the same. Moving toward the output, toward the input, you will also 1 over G and G. Okay. Any question on that? Am I too fast?
Doktor, boleh terangkan balik tak untuk summation point yang input?
Toward the input.
Ya.
This one. Okay. So when you move a summation point toward the input, okay, toward the input, all right. So you will need to multiply it with G, 1 over G. Okay, here you can see the arrow, the input arrow for the summation point is B. Okay, but after you have moved toward the input, B will need to multiply with 1 over G, meaning you need to add a block here. This block is 1 over G. After you move, before you move, there is no block, but after you have moved there, then you need to multiply with 1 over G. Okay. Basically, yes, if you just look on the rules here, you cannot imagine. Okay, later on the example, you will see how it happened. Right? Additionally, before that, okay. Mana saya dah tulis ya? Okay, additionally, summation point and peak off point, okay, these two can only be moved over a block. Okay. So for example, okay, if we have a block, then we have a summation point, we have a block. Let's say this one is G1, this is G2, right? Then we have a peak off point here. Okay, right? So we said that now we're going to combine G1 and G2. Okay, however, due to the summation point here, and also peak off point here, we cannot combine G1 and G2. Okay, therefore we will need to move the peak off point and the summation point first. Okay, so when I said that a summation point and a peak off point can only be moved over a block, meaning here, right? Okay, so let's consider this summation point here. Okay, this summation point here, I said we can move toward the output and toward the input. But for this case here, the summation point can only move toward the input. Okay, it cannot be moved toward the output because there is a peak of point there. Okay, so you cannot move over a peak of point because we only can move over a block. Okay, similarly for the peak of point here, okay, the peak of point can only be moved toward the output. Okay, but it cannot be moved toward the input due to the summation point here. Okay, because there is summation point there in between the block, so the peak of point cannot be moved toward the input. Okay, so therefore in this case we only have one choice. As for the peak of point, we can only move it toward the output. Okay, peak of point toward the output. And as for the summation point, we can only move it toward the input. Okay, so that is meant by summation point and peak of point can only be moved over a block. Okay, all right. Okay, so that is rules number 1, 2, and 3. Okay, let's go to rules number 4 and 5. Tak naklah nangis. Macam mana? Adik. Okay. All right, let's continue with rules number 4 and 5. Right. So rules number 5 here, we have what we call as parallel block. Okay, but this one here is a forward parallel block. Okay, this one here is also parallel block, but this one is feedback. Okay, you can see there is 2 block that is in parallel, but this one here is forward. Okay, toward the output is forward. All right. As for this one, this is also parallel, but here we have a feedback. Okay, we feed to the back, so it feedback, right? So here, for parallel block, okay, for parallel block, we're going to add it together, G1 plus G2. Okay, so it become, you need to sum G1 plus G2. Okay, because it is a forward parallel block. Okay, so this is G1, this is G2. So in order to combine these 2 parallel block, okay, we need to add it together. So it becomes G1 plus G2. Right. As for the feedback, okay, in order to combine a feedback parallel block, so the equation will be G over 1 minus or plus GH. Okay, minus or plus that will depend on the sign on the summation point here. Okay, if the sign here is plus, okay, if the sign at the summation point is plus, and then in the equation, it will become minus. Okay, if the sign at the summation point is minus, so in the equation, it will become plus. Okay, so that's why it write minus or plus, because it depends on the sign at the summation point. Okay, so this is G over 1 minus GH. Okay, okay, so normally for forward block, we call it as G. This is forward block is G. If it is a feedback, normally we represent it by H. It is just notation in control. But actually you can use any sign. Okay, so there is for two parallel block, we have forward parallel block. Okay, if you combine it together, that will become G1 plus G2. Okay, for a feedback parallel block, okay, we need to have to use the equation there. So the equation is G over 1 plus or minus GH. All right. Okay, one more concept that you need to understand is, for example here, if right. Okay, you can see here, the feedback is only line without any block. Okay, so for a line, okay, we will consider the gain. Normally in the block we call it as a gain. So the gain here is equal to 1. Okay, so meaning there is no transfer function there. So we consider the gain is 1. Okay, as for here, as for feedback, it doesn't matter because G will multiply with H there, so it become G only. But for the parallel forward parallel block, okay, so okay. All right. So if you are going to combine this forward block, okay, if you're going to combine this forward block, but here you can see that there is no G2. This is G2 actually. Okay, G1 plus G2. Okay, there is no G2, but we do know that for a line it is 1. Okay, so therefore the combination will become G1 plus 1. Okay, because G2 is equal to 1. Right? So for a line, okay, for any line, okay, the transfer function or the gain for the line is equal to 1. Right. All right, so that is the five rules. Okay, series block, you're going to multiply it, moving a summation point, moving a pick off point, parallel forward block, you're going to add it together, and then parallel feedback block, you're going to use equation G over 1 plus or minus GH. Right? So you need to remember this step, these rules. So we're going to use that when we're going to simplify any block diagram. Right? Right. So let's do this example here. Right. So in this example, it will show you how to use the equation for feedback loop. Okay, because this is feedback, and this one also feedback. Okay, so both of these is a feedback loop. Right. So so first, normally we're going to determine what is the type of block in there, whether it's series, forward, or feedback. Okay. So in here we know that it is a feedback loop. Okay. Second, after you determine its feedback loop, then you need to check, is there any summation point or peak off point that is meaning the summation point that we can, due to the summation point, we cannot move, we cannot simplify the feedback block. Okay. For example, maybe there are one summation point here. Okay. So if that the case, you cannot simplify using feedback block. Okay. We will need to move the summation point first. All right. And then, all right. So since in this example, there is no other obstacle, no summation point, no peak off point that we need to block, we need to move. Therefore, we can just use the rule number 5, which is feedback parallel equation there. Okay, so we know that the equation is G over 1 plus GH. Okay, plus because the sign here is minus. Okay, so we're going to do one by one. We're going to do one by one. First, let us solve for the first two parallel block. Okay, then it will become one block. Then we're going to combine it with the last block there for the K. Right? Yeah, Allahu Akbar. Okay, so the first parallel block. Sorry for the disturbance here. All right. All right. So for we're going to solve for the first two parallel blocks. So we use G over 1 plus G. So this will become G. This one will become H. Okay. So therefore, we're going to put into the equation 1 over md square divided by 1 plus 1 over md square multiply with CD. Multiply with CD. All right. So we're going to multiply it here. So we can cancel the two terms here. So therefore, the equation will become 1 over md square, because we already multiplied there, plus CD. Okay. Right. So the block will become after you combine the first parallel block, it will become 1 over md square plus cd. Okay, and then there is still a feedback loop for the k there. Alright, jatuh anak. Okay, then you will do the same step for the for this feedback block. Okay, so again we're going to use the same equation, g over 1 plus gh, right? And now this one is g and this one is h. Okay, so similarly, so we have 1 over m dwi. Ya Allahu Akbar. Mana budak-budak ni? Sorry. Kena hantar anak ni sekejap. Alright, sorry. Alright, so okay, we consider G is 1 over md square plus CD. So there is G 1 over md square plus CD. The denominator will become 1 plus 1 over md square plus CD multiply with K. Okay, so similarly, we're going to multiply it here. Therefore, we can cancel that term. So the final will become 1 over md2 plus cd plus k. Okay, so after we simplify, it will become only one block because we already combine the summation point and the two feedback block. So you just relate between FA and X, which is in here is 1 over md square plus cd plus k. Okay. All right. So that is the final transfer function based on the step of block diagram manipulation method. Okay, we do step by step. Okay, in order to get the final transfer function. Okay, so if you see this system here, okay, the system here, mass, spring, and damper pulled by force here. So it is actually the same equation for this system. Okay, 1 over md2 square. All right, so either based on block diagram, okay, because before this you already draw a block diagram for the same system. Okay, you already draw a block diagram for this system here. All right, and then based on the diagram that you draw, we simplify it so that we get the final transfer function. That later on we're going to use that in order to know the dynamic behavior of the system. Okay, meaning to get the time response time response equation for the system. Right? Any question on that? Okay, so the example number 2 just now is just to show you on how to use equation of feedback feedback parallel block. Okay, because later on you will see you're going to use that equation in most of the meaning semua akan ada most of the step in the when you manipulate the simplify the block diagram, because eventually it will become to a feedback loop. All right. Okay, let's do example 3 here. Okay, example 3. Right, so we're going to produce the system transfer function, okay, which is the ratio of input and output, C over R. Okay, C is the output, R is the input, using a block diagram simplification method. All right. Okay, let's determine what kind of parallel block that we have here. Okay, if you can see, this is all feedbacks. Okay, because this one here is toward the feedback, toward the input, to the back. Okay, this one also is feedback. Okay, so meaning we're going to use to simplify the block using feedback rules. All right, so which one are we going to start first? The first loop or the second, the first feedback or the second feedback? Okay, let's consider this is first, this is second. Okay, you can start with any. You can start with second loop, you can start with first loop. Okay. All right, so we know it is a feedback loops. Okay, now let's determine whether there is summation point or peak off point that meaning that avoid us to solve the problem. Okay, let's consider for the first loop here. Okay, what is the element that disturb the shape of the feedback loops?
Summation.
Okay, yes, due to the summation point here. Okay, we cannot combine that. Okay, if we consider the second loop here. Okay, so for the second loop, it is due to the peak off point here. Okay, due to the peak off point between the summation point and G2 there, we cannot solve the feedback loops. Okay, so in order to do that, we have to move the either summation point or peak off point. Okay, so all right. So let's say that we're going to start with a second loop here. Okay, so if going to start with second loop, you will need to move the summation point toward the output. Okay, we can only move the peak off point toward the output because we cannot move toward the input because there is a summation point there. Okay, we cannot move over a summation point then over a block. Okay, we can just only move over a block. So a block beside the peak off point is G2. So therefore, we're going to move toward the output, right? So if we move toward the output, the block diagram will become G2, and then here we have H2, R. Okay, but since we move the peak off point, therefore there will be additional block here. There is peak off point toward the output is 1 over G. Okay, right, and then this one here is still there, H1. right? So now we can solve the first loop here. Okay, so try to use the equation, try to combine it. The sign is minus, this one is plus. Okay, try to combine it. Okay, so after you combine it, it will become okay. What will be the transfer function after you combine G2 and H1? Anyone? Ada yang dapat tak? So you will become G2, G. So okay, this is G, this is H. Right, so G2 over 1 plus G2 H1. Okay. And this one here is series. So we're going to multiply it. So it becomes H2 over G2. This is G2. Okay. So, all right. So this is a feedback. Okay. So we're going to combine this one here, series. Okay. And this one here is feedback. All right. So try to solve your feedback. You will get the final transfer function. Is R and C. So the input is R, the output is C. Right? So if you combine that, so G will become, G is equal to G1, G2 over 1 plus G2, H1. Right? And H will equal to H2 over G2. Right, so putting into our equation, which is G over 1 plus GH. Okay, remember plus sign because the sign at the summation point is minus. Okay, so our equation will become G1, G2 over 1 plus G2, H1 divided by 1 plus G1, G2 1 plus G2H1 multiply with H2 over G2. Okay. So, okay, so we can cancel this. Because it's multiplied, so we can cancel that. Okay, after that, we're going to multiply it here. So therefore, the denominator will be the same. So we can cancel this with this one here. So it will left us with G1, G2 over, sana naik atas, 1 plus G2, H1 plus G1, H2. Okay. So that will be our final transfer function. G1, G2 over 1 plus G2, H1. Plus G1 H2. Okay. So I hope you will be able to see the step in order to solve, in order to get the final transfer function using block diagram simplification method. Right. So just determine whether it's series, parallel forward or parallel feedback. and then check is there any summation point or pick off point that you need to move. Okay, so if there is summation point you need to move, move it first. Okay, then you can combine or simplify the part that you want to simplify. Okay, then check again, repeat that process again and again until you get only one block that relates between the input to the output. Okay. All right, so I think I will stop here. I will share the exercise. Okay, in order for you to do the exercise so that you can check your understanding. You can check your steps there. Okay. Please do not ask for the solution because I don't have the solution, but you can try to solve it first and then show it to me, so I will be able to check it for you whether the step is right or not. All right. So with that, thank you. I'm going to see you next week because we don't have class on Thursday. All right. So our next class will be on next Tuesday. Right. Thank you. Assalamualaikum warahmatullahi wabarakatuh.